Given an integer array nums, we need to return a new array where each position holds the product of all other numbers. We must solve this in O of n time and cannot use the division operator. For example, if the input is 1, 2, 3, 4, the output should be 24, 12, 8, 6. A naive approach would use two nested loops to calculate the product for each index individually. This results in quadratic time complexity, which is too slow for large inputs. We need a way to reuse calculations instead of recomputing them from scratch every time. The key insight is that the answer for any index is simply the product of all elements to its left multiplied by the product of all elements to its right. We can compute these prefix and suffix products in two separate linear passes. Let us trace the example 1, 2, 3, 4. First, we build a prefix array where each index stores the product of elements to its left. For our input, the prefix products become 1, 1, 2, 6. Next, we compute suffix products from right to left, multiplying them into our result array. The final answer becomes 24, 12, 8, 6. We start by creating an integer array named answer with the same length as the input. This will store our final results. We also initialize a variable to keep track of the running prefix product, starting at 1. In the first loop, we iterate through the array and assign the current running prefix product to each position in our answer array. After assigning, we update the running product by multiplying it with the current element from the input array. Now we need to handle the suffix products. We initialize a new variable called writeProduct to 1, which will track the product of elements to the right as we iterate backwards. In a second loop going from the end of the array to the start, we multiply the existing value in answer by the current writeProduct. This effectively combines the left and right products for each index. After updating the answer array, we update the writeProduct by multiplying it with the current element from the input array. This prepares the correct suffix product for the next iteration to the left. Once the loop finishes, every position in our array contains the product of all elements except itself. We simply return this answer array as our final result. You might wonder about space complexity. By storing the prefix products directly in the output array and using a single variable for the suffix product, we'd achieve O of 1 auxiliary space complexity. This is the optimal approach for this problem. The time complexity is O of n because we traverse the array twice. The space complexity is O of 1 if we ignore the output array, as we only use a few variables for tracking products. The takeaway here is to look for problems that can be broken down into independent left and right parts. By pre-computing these parts, you can often avoid expensive nested loops. Try coding this pattern yourself to solidify your understanding.